Okay, we're going to go through an example where we use a PWM to control the brightness of an LED. And this is a real simple example to test because all the output bits on our PLCs, they have LEDs built into them, so you don't even have to hook it up to any external hardware. You know, the PLC itself you can run through this test with. So I'll do a setup, and in my case here I'm using ACE 11, but you know, you can use whatever one of our PLCs you've got. And the first thing we do is we need to set a length for the PWM. I'm going to make it 1 millisecond, or in other words 1,000 microseconds, and this is the amount of time that the pulse wave takes. So it's going to repeat this cycle of on time and off time every 1,000 microseconds, and we'll tell it how long to be on in a later state. Okay, so we've got that. The next thing we do is I'm going to make this dependent on time, so we don't need any external analog signal or anything, so it'll run on any PLC. But you could easily base it off something else. In this case, I'm going to do time, so I'll use a timer, and I'll call it my timer, and I'll start it. And I'm going to want this cycle to happen, let's say, every 5 seconds. So we'll see that my timer is greater than 5 seconds, so which is the same thing. It's 5,000 milliseconds, and we'll do it in this just to make it real understandable. The timer by default is, if you looked at the raw data, if you took the tag and you looked at it and you made a comparison in another function, you'd see that it's in milliseconds is what it's actually recorded in. So we'll see if it's greater than or equal to 5,000 milliseconds, and if it is, I'll just do a Control-C copy of this, and we'll reset the timer and leave it back there. We'll do this for the yes path, so if yes, it's greater than or equal to 5,000, reset, and then go back. Now if it's not equal to 5,000, we're going to go ahead and do the PWM operation we're wanting to, and I'm going to use a filter, or I'm sorry, not filter, a scale, and we'll take as input, we'll take the timer value. Again, it's going to be milliseconds, so it's going to go from 0 to 5,000, and we'll create a new tag, and we'll call it on time, and this one will need to be a UI16, and like I said, it's going to go from 0 to 5,000, and our on time, we're wanting to go from fully off, which would be 0 microseconds per 1,000 microseconds, all the way to fully on, which would be 1,000 microseconds per 1,000 microseconds. So we'll go from 0 to 1,000, so that'll scale it, and we'll connect the less than 5 seconds path to this, and then we need to do one more thing. I'm going to grab this, Control-C, and click it down, and I'm going to go to Start, and I will select an output pin. I'll just pick D1, and the on time will be our tag on time. I'll route this here, and I'll route this back, or I could maybe make this look a little nicer and route both of these to a wire router, and then back here. So every cycle it'll go through, it'll check is it greater than 5 seconds. If so, it'll go there. If not, it'll go through here, ask the question again, go through here, and the time will keep going up, and that'll cause the on time to keep going up as well. So we'll go ahead and we'll program this, and we'll run it, and I can see that the LED on my PLC it starts out pretty dim, and it pretty quickly it gets bright in this case, and we can switch to debug mode, and you can see that as the time increases, you can see that the corresponding output value increases. So it's and that's going to cause the amount of time that it's on per 1,000 microseconds to increase until it it resets itself and then it'll start back at 0. Something else we might want to do here is I'm looking at it, and it seems to be pretty darn bright most of the time. It goes from not very dim to pretty bright real quickly. So I might want to actually change the scale a bit here. I'll take it off of debug mode, and I might want it, instead of just doing a straight linear scale, we'll break it into a couple piecewise linears. We'll go with maybe 1500, and we'll go with 3000 and 5000, and we'll go 50 to 200 to 1000. So you see this scale I've got here now. It's going to follow that pattern. We'll run that, and you can see how it goes from very slow very slow increase in value up to a very quick rises. And as I'm looking at my LED, I can see that it's spending a little more time in that real dim to gradually getting brighter phase. So that looks a little better in my perspective. So I'll go ahead and I'll post these to the webpage at velocio.net/tutorials. There'll be a PWM LED dimming example, and you can go ahead and play with it from there.